Hello, and welcome to this webcast on managing customizations for Totara. I'm Simon Coggins, I'm the Director of Learning Technology here at Totara, and today I'm going to take you through some information on how to approach customizing Totara. We're going to provide some tips on the best approach to minimize problems later on, and give some practical examples to show what it can look like. Customizing Totara is a key part of our business model. We really want partners to have the ability to provide what our CEO calls mass specialization. It's actually ingrained in the four freedoms that make up our mission. So freedom to innovate covers the ability to come up with new ideas, and freedom of choice covers the ability to choose the solution that works for you and give you the flexibility. So we see that customizations are a key part of the value proposition and a key way that partners can innovate. That said, we do know that customizations can cause problems, particularly when it comes to staying up to date with the latest code. When you start modifying core code, you end up with code conflicts. The upgrade path can be difficult, and that has some real downsides. First off, you may not upgrade to new major versions because you're worried about the effort or the problems involved with an upgrade. That can mean missing out on new features which are available when we make a new release. Even within minor releases, just applying bug fixes can be a problem if you've made significant changes, and that can lead to security problems and customer dissatisfaction due to bugs. So what this talk is really about is encouraging that freedom to innovate while still providing a way to manage the upgrade paths and reduce and minimize code conflicts and problems due to those customizations. Okay, let's get started. Before we get started, I'm just going to talk a little bit about the tools I use to develop on Totara. This could be a whole talk in itself about how to develop for Totara and the best tools and approaches. But for now, I just want to familiarize you with a couple of things that I'll be using in today's session. First up is the editor that I use. So I'm using PHP Storm, which is a really good PHP IDE. It does have a good Git integration. Git is the version control system we'll be using, but for this talk I'm just going to use the command line. So I've got a command line set up here. That's just so that you can see the actual commands I'm using in case you want to use a different tool. And then finally, to actually access the site, I'm going to be using our Docker setup. You can find this on GitHub, publicly available, and this is just a development setup that you can use when testing and developing on Totara. It's really great in that it gives you access to a whole bunch of pre-configured infrastructure, so different versions of PHP, different databases. It'll capture emails and give you a web interface for viewing emails that come through. So really it's got everything you need, and I'd recommend it, so I'll be using this today. Okay, so the first thing when it comes to customizations is a question of where to put your new code. And to answer this, really our main suggestion is to use plugins. So Totara has a huge number of plugins and different plugin types. So version 11's got 440 installed just in a fresh install. And all of Totara's core code is actually done in plugins or in components. So the plugin system in Totara is designed to give you the sort of full power. You're not really limited in terms of what you can do in plugins. The advantage of having code in plugins is that firstly it's isolated, so it's separate from other code files, which reduces or removes the chance of conflicts. And secondly, you can install plugins, upgrade plugins. They have access to their own things. So plugins can have access control, database tables, they can run tasks and events, and basically everything is set up that plugins can do, everything you might need to do within the system. It's also a good way of organizing code so that you know the purpose of it. So we're going to use plugins. The next question is, what type of plugin is the most suitable? So Totara comes with a number of different plugin types, and you can see the list here. This is part of the core code that defines what the plugin types are, and then this is actually the directory where you'll find plugins of that type. Some of the most common plugins that people use is the module, which is an activity module. That's if you're developing a new piece of content that belongs in a course. Enrollment plugins can be used to enroll people into courses. Blocks are pretty common. That's if you have a specific piece of content you want to show and be able to put on different pages. And course formats is probably the next most common, which is the ability to change the layout and structure of courses. There are various others though, and you can see the full list here. Aside from this, there's a special type of plugin called a local plugin, and for customizations we really encourage you to use them for anything else that doesn't fit in one of these categories, or for any changes that would otherwise go into core. The advantage of local plugins is they're specifically designed for customization, so we'll never put anything in there, we'll never call a plugin the same thing as you. So the risk with plugins like blocks is if you create say a block called reports, and then we come along and create one called reports too, then we're going to lead to conflicts, whereas we guarantee we'll never put anything in local, so that's all for you. Okay, so we're going to get started and create our first plugin. I'm going to create a local plugin, and I'm just doing the absolute bare minimum to get a plugin up and running. So you can see here I've got a new folder inside local called custom, which is the name of my plugin. And then inside that I've created a few more folders. So one called classes, it's empty so far, we'll use that later. Another one called DB, also empty for now. And then I've got a lang folder with an en folder inside, which contains a file that we'll talk about in a minute, and then the version file. So the version file is the one we'll start with. Your version file needs to look something like this. So you define a date-based version for the plugin, which is used for database migrations. So I'm just using today's date for that. Then you need to define a version that your plugin requires. So this is like the minimum version of Totara. The version number this comes from is the main version.php file that's in the root of your folder. So it's supposed to match this version number here. So I'm on 11.0 codebase, so I've set this to be the initial version of version 11. So that means this plugin won't work on a version before 11. Finally, I've defined what's called Frankenstyle short name of my component, which is basically the plugin type plus the name of the plugin with an underscore between. And this is used in a lot of places to refer to the plugin, so it's quite important and it needs to be defined here. So you can see my plugin's called local custom. That means the name of my language file is also local custom. And I've only defined one string so far, which is the plugin name. This is the localized version for English of what will appear on the plugin management screen. So that's, I think, all you need to set up a plugin. So I'm going to just try running an upgrade as this is new code. So I'll just do a CLI upgrade. And you should see there the local custom plugin has been installed successfully. So now when I return to this page and reload, we should now see that there's a local plugin. Let me see if I can find it under additional plugins. So this is showing that it's not part of core. And if I filter to additional plugins, here it is, there's a local plugin. So that's how you get a plugin up and running. This is that language string that we defined. And that's really all you need to install and set one up. Before we start getting into details on actual code customization, I should point out that there's actually quite a lot you can do with Totara through the interface. For example, themes come with theme settings. So you can do things like changing logos, navigation colors, link colors, and button colors by configuring the theme. There's also the main menu is fully customizable, and even in the theme you can add extra CSS, so custom CSS into the theme if you need to, and then additional HTML can be used to add code into parts of the page, such as in the header or the footer. So I'm using that to add this this label here to show that this is a development site, but you can be used for other changes. Also, the advanced features area has a number of toggles for turning features on and off. So if there's functionality that you don't use, you can just disable it, and the interface should update and remove all references to that feature, which is a good way to simplify the experience if that's what you're looking to do. Okay, so we've created our plugin, and now we're going to look at making a customization. Now, for this talk, I'm going to focus on changes to core code. In a lot of cases with a plugin, you might be developing something completely new, but typically, if you do it via a plugin, that's not going to cause a conflict. So let's focus on the situation where you want to modify something about core behavior, but you want to do it from within a plugin. So how can we do that? Well, let's say we wanted to do something after the creation of a user. Here is the core function. It's in user lib, user create user. So this is what creates a user. So of course we could come along and modify this code, add in our own section here, and do whatever we want. The problem with that is that you're much more likely to get code conflicts. If somebody else comes along and changes this file later as part of an upgrade path, or removes the function entirely, then it's not going to work anymore. You're going to get a conflict in your version control, and you're going to have to fix it. So what could we do instead? Well, one of the key useful things for this is called events. And you can see here at the very end of this function, there's a call here that says whether we want to trigger an event or not, and we're going to be triggering the user created event. So that's a piece of code that we have in core, and we have events scattered throughout Totara in key places. If you want to know what they are, there's actually a report called the events list. So this can be found under reports, events list, and you can see this list gives you a list of every event that exists within the system. And there's pretty comprehensive coverage across a lot of things. So you can see for something like a course, whether a course has been created, updated, whether sections have been added or removed, reset, modules. Really, it's a very comprehensive system. We also use it for the logging. So you can use this page to find a particular thing you're interested in. So if we're interested in users, you can see there's the user created event. And this string here tells you where that event is. So let's add an event observer into our local plugin. So what an event observer is it's something that allows custom code or a plugin to listen to that event and then trigger its own code when that occurs. So I've just done this here in PHP Storm. So I've created a new file in our plugin called observers. And we're going to use this for listening to observers. I'm using class autoloading here. So there's a particular syntax that you use if you name the class and put it in the namespace for its folder in a certain way, then it'll get autoloaded. You won't need to require it, which says on memory. So I've got my file here called observers. I've just created a method here called observe user creation, and I've passed in as an argument the event that I'm going to be observing. So you can see here it's the core user created event, and I'm saying this is going to have an instance of that. Then I've also had to create this file. So this is in DB events. This is what you need to do to register your observers. So essentially what your plugin is doing is it's declaring which observers it's interested in and providing a link to the callback that you want to use. So in this case, we're saying we're going to use the local custom observers. Actually, I've got that slightly wrong. I think that needs to be using classes, local custom observers, and the observe user creation method in that class. If you want to include a file before trying to call the callback, so if you're not using autoloading, then you can use this syntax, but we don't need it here. This is just the event we're using. Finally, we do need to do a version bump here. So here I'm just adding one. This was what it was like before, just adding one to the minor version of this plugin, which allows me to during the migration, during the database migration step, it checks for new events. So that's just what makes sure that that event gets registered as part of the upgrade. So those are the three things we need. What we should be able to do now is upgrade our plugin. So I'll just go back to here, run an upgrade. The event should be registered for that observer. So to test that, I'm just going to enable debugging here. And then I'm going to create a new user. So what we should see here is that the debugging has showed that the code has reached this point. And then if we have a look at that event, you can see what we've got available in here. So I'll just expand this. So inside an event, there's a bunch of information, some of the most useful being in the data. So you can see the information about the event that occurred, the object ID. So this is the user table and the user ID. And there's a bunch of context data here, which is useful data about the event that occurred. So, for example, in this case, I've got the ID of the user who was created, and I can use that to, so that's 19 in this case, so I can use that to trigger further actions if I need to, say if I needed to look them up and email them something or whatever I wanted to do. So that's basically how it works. If you want to know what data is available in an event, you have to look up the original event file. So this is the user created event, and you can see what data gets logged in here. Also in the definition here. So in this case, what we're doing is create from user ID. So this is a helper method on the user created thing. So given an ID, it will create an event and create user from ID here that tells you what it puts in. So object ID is the user ID, related user ID. It's also the user ID in this case, and then the context of that user. So this tells you what data is being passed through into the event, and that's the data that we see when I bring that up here. So you can see if I compare these two, we should see object ID, related user ID, and context should be here. So there you go, related user ID, object ID, and context, which is the context object. Yeah, so that's how events work. Essentially, you can observe any events that you're interested in. Multiple plugins can all observe the same event, so there is a priority option that can be set. And if you want more information about events and how to configure events, then the best place to look is the Moodle documentation on events. So Moodle events here. This describes the entire system and all the functionality that's available and how to define things. So that's that page. As well as events, there's another parallel system that we also have in Totara, which is called hooks. And hooks are very similar but slightly different to events. So I'm just going to describe the difference briefly. We do have some documentation on hooks here. The idea with hooks is that they behave in quite a similar way, but they're intended to be used when you want to do something that's not a purely one-way interaction. So events typically are triggered in response to something the system has done, and then allow you to respond to that. But they don't allow you to modify what the system is going to do. So hooks are designed to be a bit more powerful, and they're designed for two-way interactions, and they're a bit more flexible, and there are less constraints. So if you have a look at this documentation, there's an example of a situation where you might want to use hooks. So here you can see, imagine some code that was along the lines of create user that would put the data together, validate that the user was valid, and then if the user was okay, they would create the user and then trigger an event. That's what the code might look like. If we were going to use hooks, what we could do is we could add a create user hook in here at this point. This is between the figuring out if the user is valid and the check to see whether to create the user or not. What this would allow us to do is add our own validation rules into our hook and actually change the result here. So we're passing in whether the user is valid into the hook, which means that the hook could actually change that value on the fly. So normally the user would be valid, but we can actually choose to say that in fact they're not valid and prevent the creation altogether. So that's just a simple example of how you might use a hook and a watcher on that hook in order to change that behavior. Just one other note with hooks and events. When you're using them, please do try to avoid cancelling the execution of code. So that would be via like a die statement or throwing an exception. Try to catch your exceptions if you can. The reason for that is that although events and hooks usually happen near the end of the flow, or at least events usually happen near the end of the flow, any interruption that happens within an observer or a watcher will actually cancel the execution of the rest of that request. So if there are either further events that other people have defined that would occur after your ones, or additional code happening, then ending the event early will end that request. So that can be quite hard for us to debug. So yeah, do try to avoid cancelling the full request, and if you are reporting bugs, please let us know if you have any events or hooks that you are observing, just so that we can rule that out if it could have an effect. So yeah, so really we would encourage hooks and events as a great way of customizing Totara without having to make core changes. If you do find that there's a place which would benefit from either an event or a hook, please do open a help desk ticket. We're very open to adding more hooks and more events in places where they'll be useful. Even better, if you want to contribute the code to add the hook, then we were very likely to pull it in. But even if you're just requesting one, then let us know where a hook would be useful, and we'll add them liberally throughout the code so that you can extend without customizing. Okay. Now we're going to go on to a practical example of working with code and seeing what's involved in dealing with conflicts and upgrading. So the first thing here is we're going to be using Git. I'd really recommend that you use Git2 as your version control system. It really does smooth this process and make things a lot easier in a number of ways, which you'll see. So I'm just using the command line here. And when you're starting a new project, the way I'd recommend you work is that first you check out a specific tagged release. So we have branches like the T11-release branch, which is the branch that contains version 11, but we tag commits along the way with a version. So when we do a release, we'll tag, say for example, Totara-11.0 would be the first release of version 11. So we do recommend you check out tagged releases. So if you are starting a new project, what you might do is do git check out the particular version of Totara that you want to be based on, and you'll see here that I'm now running on the version 11 tag, so that's the exact commit when we released it. In most cases, you're going to want to have a custom branch for every site. If I was about to start a site on version 11, I might do git checkout -b. So now I'm moving to a different branch with the same commit, and I'll put customer name here. So here I am switching to the branch, and it's still on version 11. It's still the same code. I've just given it its own branch. And now at this point, we'd start committing our work, adding commits with changes that we want to make. So I've got a branch already set up, so customization example. And you'll see here that this branch has got the local plugin that we created earlier, a commit with that in, another commit with the observer that we created in that local plugin. And then I've added a couple of extra issues in here. So one is a change to a file that's really very old and unlikely to be changed by core. So it's a core modification to a core file, but in a way that's unlikely to come up. So if you have a look here, you can see this is the file. It hasn't been modified since 2014, and I've just added a comment in here. One thing I am doing here is I'm using like an issue identifier when I'm making changes. So this is a really good practice. If you've got a bug tracker, put the ID of the issue that you're working on as comments around the code so that you can distinguish your customizations from core code later. I've made a second customization here. You can see this one, and I've done this one intentionally to cause a conflict with a later release. So we'll see how that looks. So again, I've given it a different issue ID. I've added something into a file here, and you can see these 3 lines are the new lines. And you see again how I've got my issue ID, my change, and then another comment saying it's ended, just to distinguish, so it's obvious what's custom code and what isn't. So yes, the other thing is we do have these two commits, but these two commits are both in the local custom folder, so we're not expecting to get conflicts because it's a plugin, and there won't be any other changes in core code to that particular path. So the first thing we'll show is a minor version upgrade. So I've just got a slide here to show what this would look like. So imagine that this is the commit history. So you can see, imagine commits going back in time, and the current head commit is Totara version 11.0. So this is what it was like when we checked out the tag. And then in this situation, we've created some custom commits. We've created our branch that comes off that tag, and we've added our custom commits. So these are our changes, and that's our branch name. So this is where the head of the commit would be now. Now, after a while, Totara 11 won't be the most current release anymore. So on that original branch, there'll be some new commits, which will add point upgrades to version 11. And you can see now we're at Totara version 11.19. So here we've got a tricky situation. We've got commits from Totara core, and we've got customizations, and we actually want to have a branch that includes both. So what we're really aiming to do is this. We want to move that branch and those commits that were there onto the end, so that we've got the most up-to-date version of the core code plus the customizations on top. And that's what we're going to be doing with a rebase. You can also do that with a merge. There are advantages and disadvantages to both, and we'll talk about that a bit later. So if we want to do a rebase, so I'll just confirming again, you can see we're tagged on version 11.0, and we've got 1, 2, 3, 4 commits on top. And what we're going to do is we're going to rebase. Let's rebase first up to just 11.5, so we can see what that looks like. So git rebase, and then I'm going to use the new tag 11.5. And if I do that, you'll see it says rewinding to play on top, and then reapplying those commits. So what it's done there is it's actually taken these commits away, applied the rest of the changes required to get onto 11.19, and then reapplied those commits again. And if I look at the log now, you'll see that the version that we're based on is now 11.5, and those 4 commits are still there. And it worked just fine. We didn't get any conflicts in that situation, or we would have seen it here. And that's because none of the changes that we made were changed on the branch between 11.0 and 11.5. So that's all good. If that was all we had to do, we would just run the upgrade script, and then the code would be up and running again. We're going to take this a bit further though and have a look at an example with a conflict. So this time I'm going to rebase further. So I'm going to rebase onto the latest version 11, which is 11.19. And this time when you do that, you'll see we get a conflict. So there's a conflict in libcompletion.php. And if we look at that file, here you can see why. There was a change to the core code sometime between 11.5 and 11.19, which added some new code in here. And because it occurs in a similar spot to the change that we made, we're getting a conflict. So we need to resolve that conflict now manually. So in this case, we probably want both bits of code. We'll take the new stuff, and we'll also keep our customization. And at this point, you'd want to do a lot of testing to make sure that everything was still fine. But for now, we'll assume that that change is correct. And then we can just add that change. So we'll see that that's been modified, and then we just need to do git rebase continue to say that that's been fixed. And now here we are running on 11.19. So that's the process if you want to do a minor release upgrade and you're wanting to rebase. So rebase can be used in situations where you might have a small number of commits that apply on top of a branch, and it does help keep your history tidy. But there are some disadvantages to rebase. The primary one being when you're rebasing, these commits are reapplied in order, one at a time, on top of the rebase branch. So every single one of these commits has to be essentially copied into this branch. The problem that can cause is if there are lots of modifications to the same file across multiple commits in your custom branch, then you're going to have to fix every single one of those conflicts for each commit, which can be pretty time consuming. A common problem here are the minified CSS files or JavaScript files that Grunt process produces. Because those are combinations of lots of CSS files which get combined and merged into one big file, any change to the CSS in a commit is going to impact those files and lead to a conflict. Because they're minified, they're all on one row, so you don't get any opportunity for them to be merged nicely. So if you've got a branch with lots of customizations, all of which are making changes to the theme, and you try and rebase on a branch that also makes changes to the theme, then you're going to probably be in a world of pain in terms of keeping it. In terms of applying that rebase, you're going to be fixing conflicts on commit after commit after commit. So to get around that, an alternative strategy is to use a merge instead of a rebase. So with a merge, basically what you do is you stay on your branch here, and then you just merge in the additional changes from the point where you branched off on top of your branch. So I've reset the branch that we were working from here back to where we were. So we're back to version 11.0 with our 4 commits on top, and we're going to do a merge instead of a rebase this time, just to see what it looks like. So the process here is pretty straightforward. We'll go to 11.19 directly. Now we're still going to have to deal with the merge conflict, so we do still get a conflict. There you go on lib completion. And if we go here and look at that, it's the same problem, so we'll just quickly fix that by keeping both. And then we can do git merge. Yeah, so I've added that in there, so you'll see all of those changes are there, and I can just do git commit now. You'll see I'm getting a merge commit from merging these two together, and it tells me which file is conflicted. So I've done that now, and you'll see I've got my merge commit, I've got Totara 11.19, and here are my 4 commits on top. Now in this situation, my commits are showing as the last commits on here. That's just because I've just done them all quite recently. I did them all today, whereas those changes to the branch are all happening, have all happened previously. One of the downsides of merging is that your commit history of your customizations will get merged in with the history of other commits, so you can end up with your commits not being, well, they're in chronological order, but all of your customizations aren't showing up at the top anymore. But that's just the limitation of merging. Next, we're going to look at what's involved in doing a major version upgrade. In some ways, major versions are similar to minor version upgrades in that you're dealing with similar problems, but there's the added complication that there are multiple branches involved of core code. So here's a diagram showing what the code branching might look like. If this is our main branch, at Totara 11 we'll branch off and create the version 11 feature branch. Along here, as we add point releases, we'll add commits onto the version 11 branch, and you can see here we're on 11.19. And in our case, we've got customizations on top, which are the orange commits. After 11 is released, we'll continue to add features onto the main development branch. So here there's a bunch of features that would be going into version 12, and then at some point we'll release 12 and create a new feature branch for that version. Then after 12's come out, we'll be doing monthly releases of bug fixes for 12 as well as 11. So now we've got commits happening on these 2 branches separately. If it's a bug and a feature on 12 only, then it'll only appear in this branch. But if it's a bug that was also applicable to 11, we'll create separate commits for the 12 branch and for the 11 branch. In many cases these are identical, But if the APIs or code changed in 12 in some way in that area, then you can end up with slightly different fixes on different branches. So our goal here is to get these custom commits moved over onto be based on 12.10 instead of 11.19. As we know, there's a couple of approaches we can try. There's rebasing or there's merging. Let's start with merging. So the simplest solution is just to try merging 12.10 into our branch. So let's give that a go. So you can see here I've got the branch that we merged from before, and we merged 11.19 in. So if I just do git merge Totara 12.10, you think that that might work. We know we've only got 4 changes, and only one of them changes the file that's likely to cause a conflict. However, when you do this, you find that you get a huge number of merge conflicts. This is the full list of things that are conflicting between those 2 branches. So there's a whole bunch of stuff going on there which is conflicting, even though we've only got minimal customizations. The reason for that is you're getting conflicts between these 2 commits on different branches. Although they're similar, they're being applied in different orders and with other commits in between, and it can cause big problems. So let's roll that back. If we tried to do a rebase, we would have had a similar problem, with conflicts occurring all the way across the different commits between version 11 and version 12. So what else could we try? In this example, I've gone back to a branch which has the 4 commits rebased on top of 11.19. Instead of merging or rebasing, we're going to look at cherry picking these commits onto a fresh version of 12.10. Rather than cherry picking them individually though, I'm going to squash these commits down into one to make it easier to work with. So that we don't lose our commit history, I'm going to make a copy first. So let's branch and now I'm going to reset this branch. I'm going to remove the top 4 commits and go back to the point where we were on a pure 11.19. You'll see now that the commits that were made up those, or the changes that made up those 4 commits have now been removed back to the index, so I can commit them again. Squashed changes, squashed customizations. So you can see now we've got one commit that contains all 4 of those previous changes. What I'm going to do now is make a copy of that commit hash, because we're going to cherry pick it, and I'm going to just check out the tag that we want to move to, so Totara 12.10. And then I'm going to cherry pick that commit on top. So you can see now I've got a branch that's got 12.10 with the squash customizations on top. And I didn't have to deal with any conflicts in this case. Let's have a look at what our libcompletions file looks like now. So you can see we've got the change from before and we've got our customization still. So that's how you can do a cherry pick by squashing the branch commits together. Obviously the downside of this is that your commit history on the branch is lost, so you need to make a copy if you want to refer back and see why things had changed. It can make it harder to look at which commits things were added, because it's a multi-step process. You have to find this commit and realize that it meant that the whole lot was squashed, and then locate the branch. It can be handy to put the branch name in the commit message of your squash so that you can easily find those commits again if you need it. Okay, I've got one more approach that I'm going to show you, and this one is a bit more complicated, but in some ways it's my favorite in that it avoids some of the downsides of the other approaches. So what we're going to be doing is we're going to be using a merge strategy, but we're going to use a helper branch as well to help us with the process. So we've gone back again to version 11.19 with our 4 commits on top as if we've been rebasing. And what we're going to do this time is we're going to start by creating a helper branch to help us. And the way we're going to do that is we're going to check out a branch called helper, which will create it based on the tag that we want to go to. So we're going to go to a branch called helper, checked out on 12.10, which is our destination. So you can see this is just a standard 12.10 branch. Okay, this is where the trick comes in. First, what we're going to do is we're going to do a merge. So this is a plain 12.10, and we're merging in, we're going to merge in the 11.19 branch, which is the one that we're wanting to come from. So we've checked out our destination, and we're merging in the one we want to come from. And we're using this strategy hours. So what this is doing is it's telling Git that when it tries to merge conflicts, what's it going to do? So normally what it does is it prompts you and asks you to resolve the conflict manually, but by saying strategy as, we're saying we want to use the commit or the code from the current branch, which is the 12.10 branch. So we're merging everything that's come from 11.19, and you'll see that it didn't prompt us for any conflicts. There would have been all of those conflicts that we saw before between these two branches, but we've already told it how we want to resolve them. We want to resolve them by using the 12 version because we know that's correct. So you'll see now we're still on version 12, but we now have a branch that has the commits from both versions merged together. If we do a diff here between our current commit and 12.10, you'll see that there's no differences. So we haven't changed the code, we're still on 12.10, but our history now contains those merges. Okay, so that's our helper branch. What we're going to do now is switch to the branch that we are working with, so customization example. So this is the branch that's still on version 11.19. And what we're going to do now is merge that helper branch into this branch. So we're merging helper, which is on 12.10, into customization example. And you'll see that it did a whole bunch of work, but this time there were no conflicts. So that merge happened okay. The reason for that is because all of the conflicts between 11.19 and 12.10 were already resolved in the helper branch. And Git's smart enough to know it can tell in the history if a merge has previously happened and been successful. So essentially the helper branch, by saying strategy as, is saying take all the changes from 12 when there's a conflict, and that's what we want. We can confirm that we've got what we expect by doing a diff between this branch where we are and 12.10. If we just look at the files that have changed, you'll see that the only changes are the things that the customizations that we made. So now we've got a version 12.10 site. It's running with the 4 commits that we had before, and the Git history is still intact. If we do a log and we look for our issues, you'll see that those commits are still there. There is a bit more of a messy history in terms of you've got those merge commits and things, but this approach kind of gives you the best of both worlds, and then from here you just run the upgrade step. Okay, let's look at a couple of specific examples of where code will definitely conflict with core code changes. So here I've created a couple of commits. One is an example upgrade step, and the other is change to a less file. So these are both things that regularly conflict. So let's look at how we handle the conflict. I'm starting on Totara 11.0, and we're going to be upgrading to 11.19 again. So just looking at the 2 commits. The first one is an upgrade to a core Totara module, in this case appraisals. In general, we'd recommend against doing this, but I guess there are times when you might feel that you need to do this, and if you do, you want to make sure that you do it in the right way. So you can see here I've just done a very simple upgrade step where I'm just setting a config variable, and I've done a version bump like this. and the version bump here to make sure that the upgrade runs. So this is something that you might be running on your local branch. The second commit is a change to a less file, and you'll see here a huge load of changes to the CSS file that gets generated. So you'll see the CSS file has been minified onto a single line. So any change on that line is going to cause a conflict against that line, which is really long. So, and if I just do it like this instead, you can see the actual change was a very simple change to a single file. So you can see all I did was I added one statement into a less file, and that's led to the recompilation, changing all of those, or changing the CSS files in both the roots theme and the base theme, which again, because it's a single line, is very likely to conflict. So those are my two changes. And what I'm going to do is I'm just going to do an upgrade. Let's have a look. Let's do a rebase onto Totara 11.19. So here I'm expecting conflicts, and as these are separate commits and we're rebasing, we're going to be solving them individually. So the first one, you can see it's conflicted on two files, on the version file and on the upgrade file, and so we need to resolve that conflict before we can continue with the rebase. So let's have a look at what's going on here. You can see here, these are the files. So let's have a look in here. So here's our conflicts, that file. In fact, let's have a go at just resolving them using PHP Storm. So here you can see my change on the right, the result in the middle, and the thing that caused the conflict on the left. So the cause of the conflict was some other version changes, and there was two other version upgrades that occurred between 11.0 and 11.19 in this file. So what we want to do is we want to have both of these. So what I'll do is I'll pull those in, and I'll pull these in. So you'll see now I've got that one, and also my one here. But here's where we have a problem. Although I've included all of the changes, what we need to do is to make sure that the version bumps run in a linear order. So you can see here this one actually has the same version number as the change that I introduced, and then there's another one with a later version number. So if we did this, then the first two would run. So just explaining how version upgrades work, the version file in code defines a version number. And then the database stores that same version number after an upgrade is completed. Then when you update the code and the version number changes, the system can identify that the version number in the database and the code don't match, and it will run through the upgrade looking for anything that needs to run. And then eventually it'll bump the version number and save it back into the database. So essentially we need to make sure that every one of these steps gets a chance to run. Now on our system we've already run the one down the bottom, so we know our version number. On our customized site is going to be this value, and we want to continue to run as part of the upgrade these two steps. So we've actually just got to rearrange this slightly to make this work. So let's move this one above those others. And now we actually need to change this version number. So you can see here the version number here was the same. That's not going to run at the moment. So I'm going to make that a 2. And so if we're coming from 2701, we're going to run 2702 and 2704. So that'll ensure that both of those will run. I need to update the save point as well because I've modified this. And that file should be correct now. So we've got the one that we've already run here with the version number that our site should be on, and then we've got 2 more steps here. Now we need to update version number to reflect the new one. So let's apply that change. And now look at this one. So you can see we were 1 there and we were 5 there. So we're going to take the one from here and discard this one. So that'll take us up to version 5. The reason there are some version bumps that don't have upgrade steps is likely that somebody's bumped the version for other changes, such as changes to capabilities or other reasons when you need to do a version bump to update something. Now, as long as the version is bumped by at least one number, those will apply. So it doesn't matter that it's not running through each of those individually. So that should work. So yeah, so that's the result of that one. So we've ended up with our upgrade step has got what we need. So we're going to go to version to 02.27.05. Our upgrade step will run from 01 where our change was, and it'll include these two other steps there, and that should give us what we need. So going back to Git, I just need to do rebase continue, and that will resolve that conflict, and now we get the second conflict. So the second conflict is to do with the less file. So you'll see here we've got this change which didn't conflict, but the 4 CSS files that get generated all did conflict. So to resolve this one, we just need to rerun grunt, which will recompile the less into a new CSS file that takes into account the changes from both. So I'm just going to use the node grunt runner here as part of the Docker build, just to rerun grunt. I'll leave that to run for a while. So once that's completed, we can just commit those new compiled CSS files and finish the process. Okay, now that's done, we should be able to just commit those new changes and continue the rebase again, and that's done. So you'll see now we're on version 11.19 with those two steps in place. And if you look at those commits, you can see things have moved around a little bit. But everything should be correct. And you should be able to run an upgrade now and have those upgrades that have occurred from the branch still apply while keeping the change that you made. Okay, so we've run through how to deal with code conflicts in Git using a variety of techniques. But it's important to understand that not every logical conflict in code is always going to result in a code conflict. So code conflicts occur when there's changes on both branches in the same lines, and often that can be the case. If you're making a change to the same area of code, then you may work with the same lines, and that can reflect a real problem that needs to be resolved. But it's possible to have logic conflicts without code conflicts. To give an example, if in your customization you were creating a new record in a database table, and if in the core branch a new field was added to that database table which wasn't allowed to be null anymore, then likely you'd get a logical error with your code because you're trying to create a record but you haven't defined a field that must be defined. Now your code and the core code that defines the table are in different files, so you're not going to get a code conflict in this situation, but you are going to get an error on the site. So while code conflicts can be useful to find problems, we need to do more to make sure there aren't issues when we merge code. One of the best tools we've got available is automated unit testing, and we'd strongly recommend that if you're not already doing so, you write unit tests for all of your custom code. At Totara, we write unit tests for all core code, so if you've got a problem or if you're doing a merge conflict, you can look at running our unit tests to make sure that your changes haven't impacted our site. Here I'm running using the Docker container, so I'm inside the Docker container, and this provides support for running PHP unit and bhat, which is our automated behavior-driven development testing. So I'll just show the PHP unit here. Once I've initialized it, I can just I can run the tests on. Well, I'll just run a specific test just to show an example of what it's like. So here I'm just running one test file, and you'll see that everything passes okay. So running the full suite of unit tests after you've applied some customizations to a site is a great way to make sure that our code is still working. If you want to make sure your code is still working, really you need to have written unit tests as well. So we would recommend that. Aside from that, there's a couple of other places you can go to see what's changed in the meantime. One of them is the change logs. So if you go to the Totara community, you should see under community forums, you can have a look at the release notes. And so every minor release and major release gets a link in here. So if we're looking at version 12, it's worth having a look through here and seeing what's changed in the major versions. In addition to that, we also provide information in text files in the code itself. Each module has a upgrade.txt file, which is updated when we make breaking changes to APIs. So if you're running an upgrade between version 11 and 12, I would recommend reading these files and making sure that you're not making use of any of the functionality that's changed. So that's about all I've got to cover this session. Just to give a summary of everything we've talked about, we strongly recommend isolating code in plugins as much as possible. In particular, local plugins are very good if you're not doing something that fits within a normal plugin architecture, such as a block or a activity. We recommend that you create hooks and events if you need to influence the core code flow. So if you're making changes to core code, we recommend those as they minimize the risk of conflicts and give you a controlled way to make core changes. We recommend you manage your upgrade conflicts using Git, and there's various techniques for dealing with conflicts when they do occur. We suggest relying on automated testing to allow you to review that your upgrades have not broken functionality. So that's writing tests for your customizations, but also running Totara core tests when you do upgrades. And finally, we encourage code contributions. Of course, the best diff is no diff at all. So anytime you have code changes that you feel are suitable for core, please do submit them via our help desk. In particular, bug fixes, events, and hooks are very welcome. And we'll always do something about those wherever we can. When it comes to improvements or major new features, we recommend talking to someone from our product team about the suitability of them, but we will also integrate those where possible. But certainly for bugs and hooks and events, we're very interested. That's everything I've got to cover. I hope it was useful, and please do get in touch if you have any thoughts, comments, or questions. Thanks very much.